In this experiment, we're going to be talking about the variables we use to measure gases. And so there are 4 variables we use, but we're only going to talk about 3 right here just to make sure that everyone's on the same page. So we'll talk about volume, temperature, and pressure. So hopefully you're pretty familiar with volume at this point in your educational experience. Volume is a 3D space that an object takes up. So if I use my closet as an example, so if I look across the floor of the closet, there's a bunch of lines for the floorboards. So if I measure one of these lines from the left side of the closet going to the right side of the closet, that's distance. That's one-dimensional space. If I measure the entire floor of the closet going from left to right and front to back, that's area, 2D space. If I measure the entire closet from left to right, front to back, and floor to ceiling, that's volume, 3D space. And so hopefully that's just a review. Now, temperature measures how hot or cold something is. We know if something's 30 degrees Fahrenheit, it's a lower temperature than 60 degrees Fahrenheit. The 60 degrees Fahrenheit object is hotter than the 30 degrees Fahrenheit object. But in chemistry, our definition needs to relate to particles, atoms and molecules, because that's what we're really studying. And so temperature in chemistry is the speed at which a particle is moving. So to show that, I'm going to use this racquetball. So if you're not familiar with racquetball, it's a great sport. It's like tennis, but you play it in a box. Look it up. It'll make more sense then. Okay, so if I throw this racquetball at a low speed, that's at a low temperature. If I throw it at a high speed, that's a high temperature. So low speed or low energy is low temperature. High speed or high energy is a high temperature. So hopefully that makes you think of exergonic reactions. Like combustion reactions, where we have to light a match in order to heat up the reactants. When we increase the temperature of the reactants, then that increases the speed at which the particles are moving, increases their kinetic energy, and then hopefully when they collide, they have enough energy that the bonds break and a reaction can occur. So hopefully that makes you think of it. If not, temperature is the speed at which the particles are moving. Okay, so then finally we have pressure. So when you think of pressure, you might think of air pressure, like the force the atmosphere is pushing down on you, or your blood pressure, how hard your blood is pumping through your veins and arteries. Or you might think of water pressure, like how much force water comes out of your faucet. I don't know. But pressure in chemistry is going to once again relate to the particles, specifically gas particles. So this definition only applies to gas particles. So pressure in chemistry is the frequency with which gas particles collide with the walls of their container. So one more time, pressure is the frequency with which gas particles collide with the walls of their container. So if we look at the racquetballs in the closet. So at a low pressure, we have a low frequency of collisions. So pretty relaxed bouncing around the closet. At a high pressure, we have a much higher frequency of collisions. The collisions occur more often. So low pressure is a low frequency of collisions. They don't occur very often. High pressure is a much higher frequency of collisions. They occur more frequently, more often. Duh. Hey, so recap, volume is the 3D space that an object takes up, or in the case of gases, the 3D size of their container. Temperature is the speed at which particles are moving. Low temperature is low speed. High temperature is high speed. And then pressure is the frequency with which the particles collide with the walls of their container. So how often they hit the walls. And so low pressure is infrequent collisions, not very often. High pressure is more frequent collisions, more often.